Hey guys, and welcome to another lesson in our course for electrical design. In this course or in this lesson, we will learn how to read the architectural drawing and the electrical drawing. This is important because it will help us in the electrical design of any building. So what we are going to discuss, number one, you will see these different plans that we are going to see in this video, and we will understand the difference between them and what are these symbols here. Okay, so let's go to our presentation. Okay, so how can we read an architectural and electrical drawings? First, we have this plan which can be ground floor, first floor, second, third, and fourth, and etc. They are provided from the architect in the form of AutoCAD drawing, like this one. Okay, I would like to understand what does this symbol mean, what does this symbol X mean, and etc. Okay. Now let's go and see these symbols. Number one, the symbol of stairs. They are presented in the form of parallel lines and numbered. They are usually like this. You can see them, these parallel lines representing stairs. For example, if you like this, as if you are going from down, look 67, 75, 43. So what does this mean? We start from here. Why from here? Because as you can see, 66, 67, so it means that we are going up like this, and then we go like this and continue to the next floor. Okay, so we go from the lower number and go until the upper number. We will see this in the drawings. Okay, there are other forms. You can be like this, as stairs, at which you will go like this up, and there is a flat surface, and then you can continue to the next floor. Okay, there is another one like this one. All of it is stairs, but rotating stairs. You are going like this in the same direction of the arrow. Okay, so for example, if you have these numbers, you will understand that we go from 66 to 67 to 68 and etc. like this, right? So this is the direction. If I don't have these numbers, we will have something like this, arrows, that gives us the direction of stairs. Okay, like this. It can be like this, means this is the lower point and this is the upper point. We go up like this and like this and like this and etc. Okay, so these are the symbols of stairs. Now let's go to AutoCAD program and see them. Okay, so let's look at each plan. So this is the first plan that we have. You can see these stairs here. 1, 2, 3, 4, 5, 6, 7, 8. What does this mean? It means that we are going from down here and going up to 11, then a flat surface, and continue like this. Okay, now of course you can add a luminaire here if there is if it is one floor. However, if it is several floors, you can't add it here. You can simply take this luminaire from here, activate orthogonal like this, and put it here. Okay, so it will be put in this flat area. Okay, here. Okay, now if you look here too, you will find this is the entrance of the building. As you can see, there are text in each of the plan representing each room. You can see here, these are the boundaries of our building. You can see this is the boundaries of our building, and you can see the building, or each floor, to be more specific, is divided into rooms. You can see this is one room like this, then we have this room like this, and another one. If you zoom in like this, you can see workshop like this. This is a room for workshop. Okay, you can see here office, a room for office. Then we have this part which is entrance. You can see stairs. It means we are going from 1, 2, 3, 4. It means our direction from here going up like this to enter this building. Okay, the stairs like this going up. Okay, great. Now if you look here, these are different rooms. Great. Now let's look at the next plan for a villa. Okay, so if you go down here like this, okay, this is another view. Let's go here, here for example. Okay, you can see here 1 2 3 4 5 6 7 8 9 10. So this is a representation of the stairs. You can see here up, going like this, okay. You can see even this arrow that shows you the direction of stairs. You go from here like this and like this, from 1 to 11. Okay, here the same idea. You can see here 1 2 3 4. It means we are going like this and going up like this to the next floor. Okay, great. Another plan like this one. Okay, you can see here stairs, even 1 2 3 4. You can see going down, then the flat surface and up using numbering or using this arrow. You can see the same direction of increasing of the numbers. Okay, all of them are the same. Another building here, residential building, you can see goes from here, gives you the arrows. It means you are in this floor, and if you'd like to go to the next floor, simply go with the arrow. Okay, so these are the stairs that you will find in different plans. You can see, I think it is clear right now. Okay, here again, the same idea, one going like this and etc. Okay, and this is another building, an administration building. You can see here even give you the arrow representing direction of stairs. Here the same idea. Okay, now let's look at the second important part. The second important one is our elevators which are used to it's clear what is an elevator is. Yeah, right. Elevators or lifts, depending if you are talking in the US or in UK accent. So elevators are usually close to stairs. How they are look like? They are having this symbol, you can see, and even the architect will type elevator next to them like this, or they can have these symbols or these symbols representing elevator, and this one also the symbol representing an elevator. You can see it is beside the stairs. Okay, all of these are representing elevators. Here again you can see this are stairs and elevators here. Okay, and this one too. All of these symbols which are representing like a square with additional parts or additional figures, all of these representing elevators at which we go in and out. Okay, let's see them in the architectural drawings. Okay, so as you can see, this is a residential building, and as you can see next to the stairs we have these two elevators with their own doors. Okay, of course the architect usually, of course, or all the time adds the text to these points. So for example, it says this one is a bathroom, for example, or this part is a bathroom, this one is a living room. It says exactly each room. However, this plan does not contain these texts. Okay, so let's go to another one. This one, administration building. If you look carefully here, you can see this one, stairs, and you can see this is the symbol for elevator. Okay, and this is the outro, or this is the entrance to the elevator. If you go here, you will find this symbol, and this one is also another elevator. If you go here to next floor like this, the same two symbols and etc. Now if you look at usually the architect, if we have a large building, it gives you the different floors. For example, you can see here P. So this plan representing what? Representing basement. Okay, you can see basement. If you go close here, you will find that we have here a parking area. You can see this is a symbol of cars. If you don't know, just click on it. You can see cars, which means that this part is parking area, right? A parking area, okay. um, Here, so this one is our basement. If you go here, G means ground floor, then first floor, then second floor, third, fourth. If you go down here, you will find even. We usually use these in electrical design. Okay, if you are doing lightning protection design, then you will need these elevation. You can see these are different elevations. As for example, this is main elevation, a different view for the building. This one, for example, is from the side. I remember east elevation. This one is from back elevation. This one is west. Okay, you can see here west elevation. This one here main elevation. However, this is a section, so it gives takes the main elevation and cuts a section of it. Okay, take the main elevation. You can see it gives you an inner view of the building itself. Okay, usually when we are doing lighting design, what is important for me is the height of this building. It affects the lighting protection design. Okay, so you can see basement, ground, first, south, second, third, and fourth. Now another thing that you will find here is the scale. So if you go zoom here, you will find here in this one, you can see ground floor, similar to not this one here, G, which means ground floor, as you can see here. Okay, let's just remove this unnecessary parts. Okay, like this. You'll find here project name, the name of this project that we are working with. You'll find here the date for this project. This is a very old project, but anyway, what we would like to learn is how to understand this drawing. Okay, you will find here the scale. What does scale mean? 1 to 50. What does 1 over 50 mean? It means that for each 50 meters, they are converted into 1 meter here in the drawing, or each 1 meter measured here, you can see here 5.18, okay, or let's say 5 meters. This is inside the drawing 5 meters. In reality, this 5 meters are 5 multiplied by 50, which is 250 meters. That is what's meant by scale. Each real value is divided by 50. Okay, that is what's meant by scale. If it is 1 to 100, for example, it means that each 1 meter or each 100 meter in reality representing 1 meter in this drawing. Okay, that is what these scales really actually mean. Okay, so we have basement, ground. Okay, these are the different floors, and we have just seen the elevators in them. Okay, now another part in the architectural drawing, which is the shaft or the open area. You will find it in the symbol of X inside the drawing. This shaft can be in two ways. This is a symbol that you will find usually in AutoCAD, an X. This X means that we are not going to design anything inside it. Okay, we are not going to put any luminaires, any power sockets or normal sockets or anything like this. Okay, however, this is a very important part, as you will see right now. This shaft or open area has two types: open air and double height. The difference between them is that open air, which this is the symbol for the same part, open air is available in every floor. Okay, if this symbol just available for one floor, then it is double height. Okay, so X means available in every floor in each plan. It means it is an open air. If it is existing on one floor, it is double height. What does this even mean? Let's go to the drawing and understand. So if you look at this drawing for the administration building, if you go like this, zoom in like this, you can see this is an elevator and beside is a shaft, the X symbol, right? So this is an open area. Now if you look carefully, look at this one here beside the stairs. If you go to the next floor, the same symbol, to next floor, same symbol, to the next floor like this, same symbol, and etc. It means that this one is an open air. It means that we have a large gap that extends from the basement to the highest floor. Now this open area or this open area is very important as we are going to put the riser of the building through it. So the riser of the building will go through this open area and it will supply electricity to all the panels in each floor. Okay, this can be for riser of the distribution boards, or it can be for light current system and etc. Okay, so that is a benefit of open air area, very important for cable trays for riser of the building. Okay, now if it just exists for 2 floors, if we look at this one here, if you look at this one, this is a ground. You can see here in this image here. Okay, you can see here, you can see in this one, this is ground. Okay, now let's go to next floor. Next floor first, you can see there is an X here, which means you don't design anything here. Why? Because this X, which is in this region, is similarly in this region. Okay, however, it just exists for 1 floor. If you look at this area here and this one and this one, so X only appeared for 1 floor. What does this mean? It means that this part extends to the next floor. So for example, if this part is 2.5 meters, okay, then this X part is double the height. It means that it is 2x or it is 5 meters. So if this part is 2.5 meters or any part of 2.5 meters, then this part is double height. Why double height? Because there are some application that requires double height. For example, this one is 3 meters or 2.5 meters. This is a theater, for example, or a stage. This stage requires double the height, requires 6 meters, 7 meters, whatever. So in order to satisfy this condition, we extended this roof of this one instead of 3 meters or 2.5 meters. It is extended to the next floor, which is first. Okay, then after this, you can see it is disappeared completely, which means that this one extends from ground to first floor. Okay, now let me show you another trick, okay, which will be helpful in electrical design. Let's say, for example, I would like to select this one, skip like this. Let's say I would like to select this part, or let's say, for example, I would like to change the color of all of these. All you have to do is right click like this and select similar blocks like this one. So if you go back like this, you can see this part is the only one selected. So you can change its color from here like this, or make it yellow like this, for example. Okay, so this is a very helpful trick as it will help you to select a similar object or even delete other objects. So for example, if you'd like to select all cars, you simply click on this block, right click and select similar. If you would like to delete them all or just change their color or whatever. Okay, great. So we learned about the double height and open air. Let's continue. Now also we have in the architectural drawing, we have furniture, doors and windows. So furniture will look like this. These are furniture. These are the symbol of chairs. This one is a table or a meeting table. you can see these one are representing the doors. This one is a single door and double door. So what does this door even mean? So if you look at this symbol, it means that our door here, when it is completely opened, okay, at this position, if you would like to close the door, it will go to this side. So it means when it is completely open, it will be like this, and when it's completely closed, it will be like this, okay, flat like this. So this curve representing the motion of this door. Now this double door, it means that this one goes from here, can be closed like this, be completely closed here, and this one can be closed like this. So it becomes opened in this position and closed in this position. Why this is important? Because when we add, let's say, the sockets, or when we add the switches, the lighting switches, we have to make sure that they are not behind this door, okay? Then we have this one. What does this symbol represent? This symbol representing this very narrow rectangles representing our windows. So if you look at this plan, for example, you can see this is a mat like this, and this is a sofa, for example. This is a table, chairs. You can see this is a decoration tree. You can see this is similar to TV when you look it from the plan view. You can see here this one is a door that is completely opened, and here when it is completely closed, another door. Here you can see this is exactly a bathroom. As you can see, these are, let's magnify this, you can see this part. As you can see, it is almost exactly like this one representing windows, okay? So we have here windows, here another door, furniture, and etc. Okay, great. Now let's see them inside the plan. Now let's look at them. You can see this is a plan. You can see this is an entrance. So any entrance has two doors or one door. You can see this is completely open, and when it's completely closed, it will be in this position, okay? It will be like this. Let's clear it for you. It will be rotate like this, and let's use F8, deactivate orthogonal. So you can see this is the open position. When it is completely closed, it will move like this and be in this position, okay? So if we apply the same strategy to this one too, like this, and rotate it like this, okay? Okay, so this door in the closed position, and when it's completely open, it will be right like this. This is when it is completely open, okay? So I think that this is clear for you. And this hatch part, you can see it across all of the plans. You can see here this one. This is related to the construction columns of the building itself, okay? All of these hatched parts are related to the construction pillars or construction columns of the building, okay? So when we are doing the design, we try our best to be away from this. What I mean by this, so for example, if you have a switch, you don't add it here, you add it, for example, here, away from this, okay? Great. So we have these doors, as you can see here. You can see there is also the text inside each of these rooms, WC. You can see this is representing a WC, okay? Let's look at another one. This is a villa, for example, okay? Dining room, sitting room, and etc. If you look carefully here, this is also clearly a door, a different type of doors, or a broken line due to a problem inside CAD problem. Yeah, it sometimes happen inside the AutoCAD, and instead of having the smooth curve, it sometimes becomes a broken line like this. You can see here X, which we have talked about. Here, for example, it says left. So we understand now that this X is not an open area. In this case, it is a lift or elevator. And this is the door of the elevator. Okay, so it depends on the architect, what does the architect say? You can see a bathroom with every component, as you can see, a bedroom here. You can see also the symbol representing the window, dining room with the window here, stairs, okay, a door here, as you can see, and etc. Okay, the same idea. If you go to the apartment, you can see here, this is our apartment. Here you can see this is a bedroom, as you can see here, a bed here, and this is representing here, here for example, a TV, yeah, TV here, this one representing a window, this one. Okay, of course I will know all of this from the architect itself. Let's use another plan that shows exactly this. So if you look at this plan, which is a good one for understanding, you can see here D6 or D9. What does this mean? It means door. Okay, you can see here W5. What does this mean? Window. So if you are not sure, simply if you just click like this, you will see here window. Okay, thanks to the architect. If you click here like this, door. If you look at these, you can see here these are an office. Okay, this is an administration building, so it consisting of office. You can see some decorations here, decoration plants, and you'll find here a chair with an office computer, as you can see here. Very clear, right? If you look at any building from the plan view, you will see all of this. You can see windows here, as the architect have said. If you select this one, let's see if it gives us, you can see here, elevators. So thanks to the architect, it gives us, if you click on this one, it gives you stairs. Let's see, not stairs here, like this one. We can see stairs, okay, like this. You can see here some chairs, a group of chairs, and meeting table, right? So this is all about the architecture plan. Now let me show you a complete design for a villa, which is this one, in order to help you understand how can you read this plan. So you can see this is the original plan representing location of the plan. You can see scale 1 to 1000. It means that each 1000 meter will be divided by 1, or each 1 meter will be converted into 1 millimeter. Okay, each 1 meter representing 1 millimeter in this drawing. Okay, now you can see here, this is a view for the roof from the whole building. You can see here, this are cars or a parking area. You can see here parts of the roof. Now let's go and continue. You can see this is electrical design for the whole villa. For this part, if you zoom in like this, you can see we have 2 floors. Ground floor, okay, 1 to 100 meters. So this is a scale of this drawing. Each 100 meters in reality representing 1 meter in this drawing. So if I measure 1 meter here, it means it is 100 meters in reality. Okay, so this is the ground floor. If you go here, first floor. So we have one plan for ground, one other plan for first. Okay, now you can see here that we have this part. This is very important, called the electrical legend. This legend will help us to understand what does each of these components mean. So if I go like this, zoom in any part, you can see here, for example, let's choose, for example, a bedroom like this. You can see these symbols, okay, these symbols. What does this even mean? If you click on them, you can see this is a symbol like this. What does this even mean? From my understanding, of course, it's representing what, since we have here this symbol representing a switch that turns on and off light, and as you can see, it's connected to these luminaires. So these are luminaires and this one is a switch. If I would like to make sure of this, simply go here like this. You can see here this one, you can see surface or ceiling top hang light, which means it is a luminaire, as I've just seen. Now the other one-way switch, with this one is the one which is used here. okay, this one. Okay, there is also another one. You can see here AC or split unit for the air conditioning system. You can see here the symbol which representing a power socket or a normal socket. This one is also 2. So if I go here like this, you can see here this one is a 13 ampere switched socket, okay, and this one is double pole for a water pump. Okay, this one is a 13 ampere double pole for water pump. So this is another socket here, this one and this one. This one is a twin, it means it has 2 outputs. Okay, if we go like this, you can see here there are some switches. So in order to understand this electrical drawing, we have to look at this one. You can see here this one representing the main switch board, this one which supplies electrical power to distribution ports, this one is a distribution ports. These are a chandelier, you can see here chandelier, which representing a large luminaire. Okay, this is a wall mounted light, and etc. So by looking into this, we can understand what does this symbol mean, what does this one mean, and etc. Okay, this lines are representing the wiring. Of course, in the electrical design, we put our luminaires in different lighting circuits, as we will see inside the course how to do this, and we divide them into a group of circuits. Okay, similar to this, we have these normal sockets and power sockets have also contain the same idea. They are added to power circuits. Okay, so this is how you can read an electrical drawing. Now you will see the same idea for these floors. You'll find here penthouse, floor plan, and you will see the same idea for luminaires and the switches that we have. Okay, now there is another plan. What is this plan? So we have luminaires or lighting circuits, and we have power circuits. The third thing that we have in electrical design, which is the panel schedule. When we are each of these distribution boards is a 3-phase distribution board, which contains red, yellow, blue, or the 3-phase ABC. So red, yellow, blue, that's 3-phase. Now we are in each one we have circuits, one for lighting, one for power circuits, and etc. Okay, so we design each circuit contains a group of luminaires or group of normal sockets. Okay, then we try, what are we going to do in panel schedule is that we try to balance between these phases. So for example, circuit 1 will be in red, circuit 2 will be in yellow, circuit 3, and etc. Okay, or we divide them into group of loads in each of these phases. Okay, whatever it is, you will understand this when we go to panel schedule part. So we have for each distribution port, you can see distribution port 1 for ground floor, distribution port 2 for ground floor. So in the ground floor we have 2 distribution ports. For third and fourth, for the first floor we have DB3, distribution port 3, distribution port 4 for first floor. So if you go here to ground, you will see that we have DB1 and DB2. If you go to second floor, DB4 and DB3. Okay, so the panel schedule can be done inside the AutoCAD drawing, or usually like what I would do, I will make them in an Excel file. Okay, which makes it easier for me to do it. Then the last part, which is riser and single line diagram. We usually say this one is a single line diagram, which shows you here, for example, we have this main distribution board, which can take electricity from a transformer or from the electrical grid, like from a distributor. Okay, so we have this one which provides electrical power to the distribution ports. You can see all of the distribution ports in our building are supplied from this. So you can see, for example, DB1 for ground floor, DB1, DB2, their rating, they are taken from these first floor from the distribution or the main distribution port. This penthouse and another one, DB5, DB6, and another accessories that we have. Here we can see, can we have a lift or elevator inside this building? We have a cooler, heater, and etc. All of this are separate loads that takes electricity directly from the distribution port. Now, of course, we will learn how to draw this inside the course and how to do or select the cables suitable for each of these. Okay, so cables and circuit breakers. You can see here molded case circuit breaker like this, and you can see this part representing the each of the loads that each of these distribution ports take. Okay, so this is an overview about the electrical design, how to read the electrical drawing and architectural drawing. Thank you for watching this lesson. I would like to invite you to our academy, Khadija Academy Premium membership, which will help you learn more about electrical engineering. In this academy or in the academy membership, you will find that we'll have more than 100 courses in math, electrical engineering basics, power engineering career preparations. For example, we have electrical design, we have courses on electric circuits, power electronics, ETAB, MATLAB, solar energy, wave energy, wind energy, and much more. You will find also in this academy, you will find the different feedbacks from some of our students that joined our courses. You can, for example, join our membership for just a small fee per month, or you can just have a lifetime access in which you will get all of current courses and classes, and you can have them forever. And not only this, but any new courses that will be created, you will be able to watch it for completely free. So what are the classes that I will learn in this membership? You will find different classes in electric circuits. You will find in transformers, magnetic circuits, machines, power electronics, load estimation, lighting design, lightning also design, earthing system, cables, generators, light current systems or low current systems, off-grid design, on-grid design. Very lots of classes and courses in different topics. Okay, and you will find that inside, when you join this membership, you will find this blueprint that will guide you in which classes you will start with when you join this membership. So thank you, and see you in our membership on Khadija Academy.